And it's great to see so many folks, so many friends. So today I'm going to talk a little bit about low carbon consumer electronics. So hopefully you're seeing my shared screen now.
Yeah.
And let me just move few things around here. Okay. Um, so you can see that there's a link here. This is basically a link to the slides, and you might want to download the PDF either just to have it or because there's a lot of hyperlinks on there, not all of which I have time to go through in the presentation. And a little bit of it is about video as well. And thank you so much for having me as a guest in the Wayfinding for Restorative Methods Low Carbon Conversation series, which I've been following myself. And I've met lots of you folks previously at other sessions, which are really great. So what a wonderful series. So starting off, yesterday, Toronto was flooded quite violently. So you can see there's the highway on one side, and there's the river, and they look a lot alike, except there are all of these objects sort of, So it was a very hard day for a lot of people in Toronto, and there was a lot of damage. It took me about 2.5 hours to get home from work because the city was utter gridlock because there were so many places that were impassable. So climate change is all around us. There's no denying it, and definitely even in my own city yesterday, we had an extreme weather event. So starting off, I guess I would ask what makes low carbon consumer electronics? So several things. Generally speaking, we try to use common materials with a low material impact. So there's the reduction of harmful substances, whereby electronics are made with materials which are less harmful to the environment. So, for example, materials like lead or mercury are very harmful indeed to human beings and to the ecosystem. Likewise, if we look at electronics as things we might use recycled waste in, so there are all kinds of things with plastic and aluminum and previous electronics. Could we upcycle them in some interesting way that they continue to serve our needs? Or if we've reached the end of our relationship with the device, could it be of some use to someone else rather than going in the trash or the recycling? And the reason why this is all important, of course, is that so much of the carbon that's generated by electronics is due to it being a fast cycling industry, where people basically throw out the old electronics and they go to waste, and new products get made constantly. So wouldn't it be great if we could do more repair and reassembly? There's more upcycling. There were more standards and a lot more rich repair information, which was in the open source community. Likewise, if devices really valued sustainability, low consumption, high efficiency, and an approach which you're probably familiar with if you've owned a solar calculator, something called energy harvesting, where basically the electronics device could absorb energy from its environment for its operation, basically not consume, or consume in an invisible, basically unmeasurable way, which is otherwise important. And then, of course, with all these technologies, there's a sort of social imbrication to it. Like, if you get solar panels, does that mean your neighbors are more likely to? We influence one another. And a lot of things are considered professional or not professional, socially acceptable, socially not. Basically, we influence each other in all sorts of positive ways, but also sometimes it prevents us from changing as rapidly as we might need to. Just taking up the threat of, it might be too late. So along those lines, these are all devices that represent things that were thrown out. So this is like a thrown out chair. This is an old iMac foot. And this I got at a garage sale. It's sort of an old suitcase, which I'll show you what it is a little later on. But basically, it's an entire workstation and outdoor stereo powered by the sun. And obviously, not everyone wants to work outside, but it's kind of a nice thing. Now, part of my thesis involved looking at about 100 different electronics devices, so collecting them. And it took a really long time, about 7 or 8 years. Some of them I had help from Russian colleagues who were graduate students. Others I got from as far away as South America. So, basically looking all over the world for these devices which use energy harvesting in the history of photovoltaics. So basically, solar cells were invented in 1954 at Bell Labs, and an awful lot of things got made. But basically, it's not very common to find electronics that have solar cells in them. And got to wonder if we couldn't be a little more sustainable about that. So this particular one stands out, the Hoffman from 1962. So Hoffman, so I've added more tabs here so you can read a little bit about Hoffman. But they made the very first solar cells that, like, basically the commercialization of the Bell Labs discovery. So they made the first solar cells on the Vanguard satellite, which was America's first satellite after Sputnik. And they launched a series of consumer electronics devices which had solar cells in them. And what is special about this particular one is that it had a special circuit for recharging what we normally consider to be single-use batteries from the solar cell. So basically, if you trickle charge it, and you don't do it in a really steady way, because the redeposition of materials in chemical change sometimes requires an oscillating voltage or a voltage that varies. So essentially, it facilitated people reusing their batteries for up between 4 and 25 times. And at the moment, we're throwing at batteries at the rate of 15 billion per year, which is a huge amount. And if we're trying to make our economies go towards electrical devices, chances are we're going to use even more, and recycling will become even more important. So is there something that we could do about this, that we could do differently? And some other great features, it has a chrome steel chassis, which is really incredibly indestructible. Imagine a chrome bumper from a Cadillac from the 60s, and basically that process on the front of a device. So it makes it a little bit heavy, but it also makes it extremely strong. And also has an interesting, the manual for this device actually had a civil defense section. Imagine an electronics product nowadays having a civil defense section. So you see these triangles here, those appear on the dial. They're basically what you turn the dial to if there's a nuclear attack, which of course we are very successful to avoid. So maybe climate change will avoid some of the worser effects eventually. Once people get together and organize and prevent more harm from happening. Another really great device in the history is something called the IKEA Sunnen, which is from 2008 to 2010. So I found the history of it, which I've linked in the More tab at the IKEA Museum. But basically, it had this really interesting thing where they sold about 500,000 of these, and they donated 500,000 to villages in India and Pakistan, which had no electricity, so that to promote literacy among children, attending school. And so this idea of a sort of socially imbricated sales model is really interesting. Aside from that, it's also really efficient. So it has this packs flat mantra that IKEA has for all of its furniture. Everything is like flat. You always have to assemble it, which has some interesting effects psychologically. So you tend to value things more that you make yourself. That's called the IKEA effect. As well, it also used something called a lithium iron phosphate battery, which is less common than the ones we use nowadays, mostly, which are the kind that you find in laptops. But essentially, they don't have that problem with thermal runaway. Maybe you've heard of cell phones exploding and, problems with batteries. These batteries don't have that problem, and they last a lot longer. They just don't store quite as much power. So for whatever reason, the industry has kind of passed over them in terms of really making a lot of use of them, although we're starting to find them more now. Likewise, high efficiency LEDs and the power units, you can actually take them out and recharge them on a windowsill separately from the light. So you didn't always have to put the light out in the sun. You could leave the light where it is and just take its power unit out, put it back later when it's charged. So it had a lot of great design features. And it's my constant companion as far as bedside reading. Now, of course, there were a lot of other really interesting devices. These are some solar powered smartphones. Basically, they were created around 2009, 2010. So here's a laptop from Samsung. So you can see that it has a solar panel on it. This one was called the Blue Earth, and this is the GD 510, I believe. What was interesting about this one is that the regular model of this had a regular plastic case on the back, but you could swap it out for a solar cell one. So it was like an accessory you could buy that the phone would then recognize, and then it would tell you how much carbon you saved from charging. And a recent study by Angela Renders, who wrote this great book about solar engineering, was that if all our cell phones had solar panels on them, we could make all the batteries 30% smaller without people really seeing any effect as far as having to charge it and so on. So we could have reduced a lot of consumption by means of one of these product things. Now, the reason why they didn't catch on probably has to do with Apple. Apple took out about 5 patents for solar-powered devices, even though they never produced any. And around the time that these came out, they became embroiled in patent wars with Samsung. So you may remember the curve of the iPhone was actually something that they thought might be patentable, and that other smartphone users or designers were stealing. So there was a lot of litigation about this for a period of about 10 years, which led to a lot of uncertainty around the use of the devices. Okay, so there's a few historical examples which I think are pretty cool from my study, but there's actually like around 100 of them. And then a lot of them have really interesting features of other kinds. So I guess the question is, if you're going to make a speculative design, make your own device, why not make it energy harvesting? Because I mean, a lot of Internet of Things smart devices are starting to be powered quite commonly by ambient energy in various kinds. Why don't we make more common things that we use solar powered or simply not consuming? And then of course the other thing is devices themselves really last a long time. The e-reuse project found that 85% of computers that get discarded are actually still in working order and could be rehomed. And it's such a waste that we get rid of them just because they're a little slower than or not quite as optimal, or for whatever other reason we discarded them. So, basically a lot of devices are getting gotten rid of that could otherwise be being used. And this fast cycling industry norm that we have really needs questioning. Now, as far as design is concerned, you often need to think about your energy experience. So how much energy storage do you need to have versus energy harvesting? So what that translates to is either battery or capacity storage, or the electricity that you collect, versus how big a panel do you actually need for the device. So in this case, the one over my shoulder is about 20 watts in full sun. And then there are some other principles which I've sort of remixed in from other organizations. So the open hardware people, this is actually their mug. You see it's got these funny electronics on them. But anyway, the open hardware folks talk about no black boxes, the idea that electronics and devices should really be transparent. And so, for example, the open refrigerator project, the Frigidaire, the speaker talked about how refrigerator compressors are literally outsealed to black steel, and he had to pry it open. And so, it's not a metaphor for no reason. The idea of a black box, sometimes it is actually a black box. And then, of course, the limits community, which writes a lot about computing in times of limited availability of resources. Really great group of scholars. They have this concept of transitional devices. And from that, I sort of proposed the idea that you consider a lot of your electronics that you own as transitional. It's something that's going to be transitioned to something else. So, whereas we normally talk about electronics products, maybe they're not actually, the end of it. Can it be something else? Or maybe it's for someone else. So in that sense, we're just passing through time, and so are our products, but the products themselves might be transitional in a lot of ways to something else. Now you might, if you have, I guess, if you're going to engage in electronics, you need a few things. Generally speaking, multimeter is really useful. And if you have reading glasses like me, then a large display one is really great. Likewise, a lot of scrap wire is useful. Wire cutters, I find these cheap ones actually work as well as these really expensive ones. So, and you can sharpen them. So, no big deal there. Alligator clips are really great for prototyping. And those nuts that you use for installing light fixtures, they're called acorn nuts. You can actually twist a couple of wires together and use an acorn nut to hold them together. And I mean, it works inside a light fixture. So why not something that you're prototyping just to see how it works? And then, some other things, adjustable voltage supply. And if you get into using lithium ion batteries, this Litocala charger is really great because it can tell you if they're good or not. And I'll talk a little bit more about that later. So a quick poll in the Zoom chat. Do you identify as never DIY, you never fix anything, or occasionally fix something, or you often DIY fix things, or you always do? So take a moment, and if you have a mind to, stick in the chat where you are on that spectrum. How do you classify yourself? Okay, so we had some occasionally. That's good. Fearfully, that's funny. Yeah, more occasionally. Okay, so lots of different places, and yeah, Dawn I'd actually put above occasionally, but up to you. Yeah, that's great. Okay, so very occasionally from you, Ron. Yeah, thank you. All right, so we're in different places on the spectrum. It's really a journey, and you might start in one place and end in another, depending on the kinds of things you need to do. We speak a lot about situated learning. Oftentimes something breaks and you got to fix it, and that's a situated learning situation where you really need to look at things. Now, a lot of the problems around electronics, so now I'm going to get a little more technical. So that was sort of the soft lead in, hopefully. But a lot of the problems around electronics I find have to do with voltages matching. You probably own a lot of transformers, these things that you plug in that charge things, and they're all different sizes and they're not universal. Although, with USBs, it's gotten a little better, but, a few decades ago, there were transformers different for everything. So, these two monitors have different transformers and they're not interchangeable, for example. So it's very useful to have essentially electronics devices that you can use to modulate the DC voltage from one voltage to another. So the most cheapest and most useful one that I found is this one. It's 66 cents. And you can use a screwdriver to adjust the voltage that you want to come out of it. Or if you cut the lead at the back and just put a blob of solder across this, it's called a jumper when you do that, you can set it to be a specific voltage. So if you have a 5-volt Raspberry Pi, then maybe you need to set it to be 5 volts. Whereas if you're using Adafruit Feather that's 3.3, you might use that. Or if you're lighting an LED, which is only at 1.8 volts, and you don't want to burn it out, this is pretty good for that. And these are very efficient as well. They're something like 80 to 90% efficient at changing voltage. So you lose a little bit of energy, but not too much. And then a little bit larger. So here's the input voltage from one side, and here's the output. And you adjust it with these two screws. And you'd use a multimeter to set it to the voltage that you need, which I'll show you how I use that in a minute. If you need a really big one for a lot of wattage, it would look like this. So in the upper corner here, you can see it's got a heat sink, so it cools. Some of them come with fans, but I mean, if you're trying to conserve energy, it's not a good thing to have something dynamically running. And then finally, this one's really cool. You just use the buttons to adjust the voltage, and it tells you continuously what the power is flowing through it. And this I use on my shed, which has got two 250-watt 40-volt panels. So essentially, it's a lot of electricity. So it doesn't matter that I'm running a tiny LCD display from it, because the purpose is to charge a battery bank or a capacitor, in this case, a capacitor bank. And, if I ever eventually get an e-bike, I'll probably charge it up in there from solar instead of from the house. But we'll see. From now, I'm just using regular bike. Okay, so I mentioned, I'll show you how I used the middle one. So this is the same one here. They're really quite cheap, $2. This particular boombox I found in a residence e-waste. So, the students move out, they leave a lot of stuff behind because they're traveling and they can't travel with it. So this was a Sanyo stereo, just needed a little bit of contact cleaning. So essentially I hooked it up to this 12-volt solar panel. It's hanging on the wall here. And this DC to DC converter, basically I used the screws to regulate it down to the voltage that the stereo needs. So very easy to convert this stereo to run on solar. Just a $2 DC converter and a solar panel, which you can pick up quite used. It's an interesting social problem that roofs are designed to only last about 12 years, but solar panels last for 25 years. So really, there's a kind of mismatch there, and results in there being a lot of used solar panels on the market that you can purchase quite cheaply. There's a place I go called solarshoppingmall.com in Mississauga. And you may wonder what I've done in the battery compartment here. These are actually supercapacitors. So they're wired up in series. So this stereo can run by itself without the solar panel, but only for about an hour. It's not really a lot of time. And part of it is that it's a loud stereo. And the other part is it's not very efficient. So this was sort of an early project, but it was a sort of a low barrier to entry. It didn't really cost very much, just hacking around sort of thing. And you can see the lots of alligator clips. No point in wiring anything up permanently if you're just testing it out. Then I got further into looking at capacitors. So I discovered that there are just in addition to the early solar calculators, which we associate with not having batteries, Citizen makes these interesting watches. There's a Citizen watch, and the back of it won't actually open. Basically, it's not intended to ever be opened because it has a capacitor in it and not a battery. So it's an electronic watch, but it's powered by something which is recharged by a solar panel on the face. So there's a solar panel behind there. So this is a really great strategy, and it's been successful for something like 40 years. And it's called EcoDrive, and it's kept hundreds of thousands of watch batteries from landfill, because basically instead of having to use a battery, it just uses a capacitor, and capacitors recharge 500,000 to 1 million times. So come 2010, these watches use supercapacitors. Come 2010, we're starting to make them in really large sizes. So 350 farads, 3,000 farads, they're about the size of a juice can. And come 2020, they actually work out how to make a battery and a capacitor together. And it's called a hybrid supercapacitor. So it's like the electrode from a battery, but a supercapacitor surround that stores the power. And capacitors last so long basically because they store electricity like static charge instead of chemical change. It's also the reason they get soldered onto electronics as part of the permanent components, because they last a really long time. They last decades, even 50 years, 60 years. I mean, you may have heard of old electronics getting new capacitors, but it's actually quite rare. They usually still work. All right, so Eaton made these ones originally. So this one's about 220 farads. And then just a couple of years later, they were making them 5 times larger, so 1,100 farads, and at the same price. It sort of supports what I was saying about batteries that are disposable being the same cost to manufacture as batteries that are rechargeable. And why aren't there more of them in the stores? Why don't we basically outlaw them? But anyway, they are still pretty useful. So now looking at some devices that sort of derive from that. First thing is this is an iMac foot. So basically from an old iMac. And I've attached a 20-watt solar panel to it. And what is interesting about panels that are rated for certain voltages, this one makes 12 volts because it's intended to charge a 12-volt battery. But when you actually attach it to capacitors, it goes to its open circuit voltage, which you can see is more like 20 volts. So you don't want to put too few capacitors thinking it's the same as a battery. No, you actually need quite a few more. It needs to be at least up to the level of the open circuit voltage of the solar panel. So that's one of the first and most important things that I learned. And then beyond that, if you're going to make something that's like a stereo, I mean, obviously you don't want to buy things as little as possible. You want to make use of the e-waste. So in this case, this beautiful aluminum foot from a 27-inch iMac. And then these speakers are from an old GE boombox, which was in really rough shape. The tape deck wasn't working or anything. It was being held together with duct tape. So I just harvested the speakers off. But, they have a few problems. They're actually cardboard and not really strong. Here's a smaller one from a smaller iMac. And in this case, you can use it to power different things. So in this case, you can see there's a radio unit that I've fitted to it. And I've also used the speakers from the iMac. So these are iMac speakers that you can see, and they're actually quite good. And then the power unit is just sort of hanging down here because this is my personal one, and I don't really care how it looks. but I'll get more into radio design a little better later because I have a better one. So, as I was saying about transitional devices, I rebuilt it again with better speakers. These ones are from conference speakers. So they're full aluminum. So they're a lot higher quality and they go a lot louder too, which doesn't hurt. And then you can see on the back, probably a lot of you have some kind of music player like an iPod Nano. And, remember when devices had actually FM tuners in them? So like the original cell phones had FM tuners in them. Where did that go? So if you want to take an old music player and make it useful again, you can make it part of a nice stereo, standalone stereo. So here you can see there's the bank of supercapacitors, so the gray ones. And then here's the Bluetooth amplifier that's, it goes really quite loud. It's good. So here are the really large ones that I was talking about that I think are really great. So this is like about $300 worth of them. Now essentially so that's like $13 a piece. And you can see that they come wrapped in the plastic and also sealed like this. And when you take them out, they also have this little sleeve here on the positive lead. And the reason is because like batteries, they come fully charged. But unlike batteries, when you touch the positive and negative together, it doesn't just spark, it melts things because capacitors can discharge really quickly. But what is important about this is, it's not actually that dangerous. It's only 4 volts. So all of these supercapacitors, ultracapacitors, they're all very low voltage, nothing that's going to harm anyone unless it causes a fire. So if you have doubts about it, it's useful to work outside. Whereas if you're more experienced, just take precautions. So what I did was I took the smaller supercapacitor stack and put a larger one on, and now it can store a lot more energy. But still, it's actually not that much in terms of, it being a stereo. But definitely, if you walk in front of the panel or it gets cloudy for 20 minutes or half an hour, the stereo is going to keep working. It's perfect. So most interruptions that we would normally get from intermittent ambient power, this can pretty much buffer and, remove that irritation. The other thing you can do, of course, is just turn the volume lower. So you can respond to your environment. Oh, it's a little cloudy today. I can't play the stereo quite as loudly as I might normally and annoy the neighbors. Yeah, so I think I put a link to the video there, but just moving on. All right, so where this is maybe a little more important and accessible is where you build things that aren't like large productions. So in this case, it's sort of like a test circuit. And some of you might be familiar with the TP4056. So it's this tiny little board worth about 20 cents, and it's used to charge lithium-ion batteries. And lithium-ion batteries normally go from 3.7 to 4.2 volts. So what we need to do is just figure out a way to make this charge the capacitors, which go up to 3.8 instead of 4.2. And the way that I've found works pretty well is you just use a diode. This is like a whole roll of diodes. And essentially it just makes the DC go in one direction, but not another. And in the process, it drops the voltage by 0.4 to 0.7 volts. Schottky diodes, which is the kind that I use, actually are very low voltage drop. Because basically, we're using so little energy, we have to be very efficient about it and, try not to consume as much. So you can see what's happening here is you can take this old BlackBerry transformer that I showed you. I don't have a BlackBerry anymore. And you can, plug it in, and with the diode here, through the diode, you can charge this capacitor. So what can you do with it? Well, obviously, they're really great, bright LEDs now. So Yeah, so here's one of these LEDs, so maybe a 3-watt one. And you can see that basically it's being powered by the circuit that I'm showing you. That's the back of it. And I've also got a solar panel, which is charging as well. So if I don't actually have to plug it in to charge it really quickly, sometimes I could just make one of these lights. Or it can be an emergency light or a patio light, and it will actually shine for a really long time, like at least a couple of hours, very brightly. So what could you do with something like this? Well, how about a bike light? So in this case, I've taken LEDs that flash. So that's this bag here. And I put links to all the things that I used. So if you decided you want to make one of these for yourself, by all means, and get in touch if you have any problem. So you might need a proto board. You might need to reduce its size to fit in the tuna can. So there's the cat in the tuna can. And this is what it looks like when it's sort of a, so you can see there's the TP4056 with a switch. And essentially what it looks like is this. So this would keep flashing. So it's not super bright right now because I have all the lights in the house on, but it's actually quite bright in the dark. And if you watch the videos at the links that I put on the slide, you can see that it's really quite bright in the dark. And it will go for quite a long time too. So in that sense, you could make yourself a batteryless bike light. So, you made it yourself. You made it out of an old tuna can that got discarded. Mott's Fruit Station's apple cups are particularly good as reflectors because they've got all of this striated texture. It's supposed to look like a barrel, I guess. And so it scatters all the light, just like a regular light scatter thing that you would buy. That's commercial. So in that sense, it's pretty good. Here's a photo of it, but I actually think the videos are better. So if you want to make that, it's actually pretty simple and not a big investment either. 20 cents. The hybrid supercapacitor is probably the most expensive thing. It's like $10 and 13 if you use the really large one. So moving on to the really large one. So in this case, I made a headlight for the bike as well. So you can see essentially, again, it's the TP4056. There's a diode, which drops the voltage so that it doesn't go all the way to 4.2 because the limit of these is 4 volts. So it charges perfectly and stops charging when it's full. Likewise, you could fit it with a solar panel if you wanted on the top. So while your bike's parked outside on campus, the sun could be charging your capacitor. And the LEDs are quite cheap. You can buy them in quantity. And also the reflectors as well. So I just need to find a way to make this a little shorter and, fit really tightly. And then it'll be a really good bike light. And also attach it a little better than, using one of these things. But basically, it works very well. Now, this project is a little bit longer. I've had for a longer time. Essentially, it's a batteryless FM radio. So it's based on the public radio, which is an open source crowd-funded project by Zach Dunham and Spencer Wright. So if you go to the link, you can actually still buy one. They're like $100 now because I think they've stopped selling them. They sort of put their business over to someone else and they raised the price. But they're still really great radios. So this is what it actually looks like normally. It comes in a tiny mason jar, and then it's just in the cap, and you can see the batteries are here. And with the batteries, it will work for about a week. But of course, you end up throwing out the batteries if they're single-use batteries, or you might have to recharge them. So these ones are rechargeable, but they still only recharge about 1,000 times. Wouldn't it be great if they could recharge 500,000 times? So I enter these various prototypes here. So here it was working for maybe 2 hours from these 2 supercapacitors. Then I added another set of 2, so get it up to about 4 hours. And initially, I was using sort of scrap solar panels from those lights that people put on outdoor lights that they put on their landscape. They also throw them out when the plastic breaks. So there's this kind of a steady supply of those, I'm afraid, in the e-waste. Then later on, I figured out how to use a specifically designed panel, which is a lot better and uses less parts. And you can see this one has the supercapacitors sort of facing end to end. And this one, which is sort of a more final one, has got the really big hybrid supercapacitors and 6 of them, and it will go for about 75 hours. I've never actually reached the end of it not being able to play the radio. Because really, I only listen to about 2 or 3 hours of radio in a day, and the sun comes up every day and it recharges. So, you know, it's the kind of thing that all the friction around the energy experience is kind of out of there if the tank is large enough. On the other hand, the solar panel is actually too small for me to just power the radio off of it. So in this case, the storage tank is super large, and the energy harvester is actually quite small. But imagine if your electric vehicle could drive Canada, coast to coast across Canada, end to end, just because they found a way to store enough electricity. So it's sort of like that. And that's the thing that would really make the energy transition a resounding success. If we can make things which surpass what we have now, then people would really want them, which is something that the Italian designer spoke of. There's a moral imperative to change the things that we use, but really what's more effective is just to make it work better. And that'll convince more people. All right, so, further to specific panels, in this case, I mentioned that when you charge capacitors, the panel goes up to its open source voltage, or sorry, open circuit voltage. So in this case, it says this is a 3-volt panel and it's about 1 watt, but it's actually charges all the way to about 4.5 volts, 4.2 volts, because it's charging a capacitor. So in this case, we put a diode in there to keep the electricity from seeping back into the panel. So regular solar panels that you buy normally have a diode in them. But in this case, because it's a bare panel epoxy product and very cheap, it doesn't have a diode. You have to add one. So basically, adding a Schottky blocking diode makes it possible for the solar cell to charge up the capacitor and then stop charging it when it's full, and you don't need all of this electricity voltage changing regulation happening. It's a lot simpler and fewer parts. Now, at the other end of things, when you're actually using the electricity, you don't want for it to go down below 2.2 volts, because then you start to damage the capacitor. So in this case, voltage regulators for the product that you're making often cut off at a specific voltage. So in this case, the public radio actually cuts off at 2.5 volts. So there's a sort of natural protection to the capacitors that are using it. Otherwise, if you're actually experimenting with it, Pololu makes a special regulator that you can adjust the cutoff voltage. But they're like $20, compared to, say, the 66 cents one. So, if you want complex capability, it really costs compared to sort of mass-produced things that are just generally useful. Now, you can control the energy use with the regulator, the solar panel, and also the let's see, regulator, solar panel. Yeah, so the solar panel is the top part. The USB charging part of it, also we want to not exceed the voltage of the storage. But sometimes just the IoT device can read its own voltage and then shut itself off so that it doesn't overcharge or undercharge type thing. So in this case, if the computer draws less than 6 volts, the computer actually goes into deep sleep, which is what IoT computers are really good at. So essentially it suspends its operation, and then occasionally it raises an eye just to check the voltage again. Maybe you can set the interval, but it would be like maybe for a split second every minute. Oh, is the voltage back again? No, it isn't. Okay, back to sleep. Oh, is the voltage back again? No. Sort of like if you're kind of sleepless. So anyway, I made a video of the whole process where I sort of explain what all the parts are and what it does. But this was sort of an early experiment. And yeah, what's cool about it is that the computer's actually reading its own energy supply and then responding dynamically. And then the other cool thing is that it's actually an ebooks hotspot that can serve the 30,000 ebook volumes of Project Gutenberg, which were actually released in a DVD collection. So it's pretty easy to find online. Now, if you want to make even larger stereos, so, the smaller things are kind of good for degrowth and so on. But what if you wanted to make things really large? Where would you find parts? Well, actually find if you go to the auto wreckers, there's like very expensive stereo systems in luxury cars. So this particular one is from a Volvo. And you can see it's kind of a funny shape because it was in a door. and there are audio implications for that. But what's great about it is that it's got the tweeter and the woofer sort of together, which means you have a really great audio quality. And instead of having to hook up all sorts of different speakers and attach them, it's sort of one unit. So this is really convenient to get hold of. And normally this quality of speaker would actually cost, quite a lot, a few $100s. In this case, they had free parts days, and it was all you can carry. So I got a whole bunch of speakers. I even got this giant speaker from an Lexus. And there's another one from Mercedes. So, those are for larger projects. And you can get the Bluetooth speaker amplifier in different sizes. So here's a really small one. Here's a larger one. So you can see the little antenna on there for the computer that connects to your Bluetooth. But this particular one also has a USB-A plug, and you can put an SD card. And then there are other ones which sort of focus more on amplification. So with a really large speaker, you probably want one more like this. So, same features. You can put in USB and an SD card, but in this case, it's got a lot more amplification. So you need a pretty decent solar panel to power that thing. In terms of tips for working in the scrapyard, generally speaking, you want to bag everything really promptly, and you want to limit getting mud into things. So that's really good. I just bag them as soon as I take them off. I mentioned about combination speakers. Generally speaking, it's really hard to remove things off cars. You have to know exactly where to pry. And sometimes European cars, which have often great stereos, use hex or star screwdrivers, like bicycles. So you might need particular things. So you want to watch a few YouTube videos before you go. And some yards actually, tell you which cars are in which aisles. So they're really easy to get. All right. And then, of course, some of the downside, well, they're kind of heavy. And sometimes they have really weird brackets, which wouldn't fit in your design natively. So you have to sort of hack something. But there's no comparing with, reusing these e-waste. It's so great that we can do this. Now, I wanted to have something that you could make relatively easily from this talk. So this particular project, which is behind me, I'll just move the radio here so you can see it a little better. So it's got these speakers that I got off of, e-waste basically. Then it's got an iMac foot. This particular one's from a 27-inch iMac, so it's nice and sturdy. The solar panel was only about $45, so there's a link to where I got it from. And then there's this really, really cool thing you can buy online for just something like $4 or $5. So here's one. It comes in a bag. So I bought a few of them to give to friends. And essentially, it's both a lithium-ion battery charger. It's also a source, so you can charge your phone from the battery. But also, it's a speaker amplifier. So it's got these two plugs for each of the speakers. And all you do is you just attach the wires from the plugs to the speakers and add a battery, and then, something to charge it. And so in terms of charging it, I've got this 12-volt panel, and then it goes through a 12 to 5-volt voltage changer, which is also very cheap. So the next picture here sort of shows the pieces. So this is what it looks like here in a little more detail. So very easy to get hold of, and so is this. So basically, you'd use this in your car to charge your phone from the 12 volts of the car. Probably don't need to buy a cable because most people have one lying around. And, a solar panel is, not that expensive. It's small. You could even go with a 10-watt one, but I kind of like having a lot of storage. Is partly, I just like music, so I like to play it loud. But anyway, so in this case, you have the solar panel into this, and then this voltage back into this. Now, in terms of it being sustainable and low carbon, well, I mean, you do have to buy a few new things, but the foot is e-waste, the speakers are e-waste, and actually the batteries are also e-waste. So basically the battery is from something like this. So in the upper right corner here, you can see there's this is a removable battery from an old laptop. And typically they fail because one of the three batteries is bad, or two of the three batteries. Sometimes it's all of them, and but oftentimes you can actually get one that's working out of there pretty easily. Obviously, there's a lot of warnings on there about taking them apart and being careful about it. Generally speaking, I would do this kind of thing outdoors on concrete with safety glasses and, maybe some gloves. And, basically just use common sense not to short anything out or use really sharp tools to puncture anything. But it's usually pretty easy to extract these 18650 standard batteries out. And many people have used them in other projects. There's a ton of videos online of people, recycling batteries out of old computer packs. So you can get a lot of things out of e-waste bins, and you can see, this is where you might get a foot. So here's an iMac upside down. It's in distress, and it's got an aluminum foot there, which could be reused if, someone came by to harvest it off there. So it does take a bit of taking apart, but one of the great things is sometimes you can use parts of the steel frame that are inside to attach the iMac to. Other times you have to add a little bit of wood and some screws, but this particular design is really good. I thought you could actually use one of the painter stir sticks, but it's maybe a little on the thin side because people give them away for free. So yeah. So making this is actually really quite simple because you don't need to solder anything. It's just attaching a few wires, and you could even do it with alligator clips. So I recommend this recipe highly. It's quite effective, and it produces a really usable stereo. And those speakers can go for about 2 hours, 3 hours from that battery, because the batteries do store more power than capacitors. But in this case, like I said, because we're reusing them, seems to me that it's fair game. Now, can we do more serious devices? Well, it is possible to make a laptop work from capacitors and not a battery. So here's like a bank of them. And then you see I've got my DC to DC converter here, the $2 one. So it's producing the voltage that the laptop needs. But it is a little bit hard to maintain. So, I have a bit of work to do to make that really reliable. So I was actually thinking, it might actually be better if we could use our standard laptops with more recycled stuff. And part of being able to do that is having a sense of how much power you're using. So this is actually the power meter on the laptop that I'm using right now. So it's basically the MacBook Pro ARM processor that you see in the picture. And you can see in the meter, it's actually only using about 22 watts, which is really low for like an iMac would often use over 100 watts before they had ARM processors, when they had Intel processors. So our computers are becoming efficient enough that we could actually have solar panels on them quite often and power them from there. So here we have the 20-watt panel that I showed you. And then here's the 5-watt converter. 5-volt converter. So 12 to 5. And then if you just plug the USB-C into the laptop, and you can actually prevent the battery from discharging. Or if you actually put it in sleep, you close the cover and it's only using about 6 watts, but the panel's producing 20, it would actually charge it. So this is a pretty great mobile workstation concept, I think. And essentially it was like an artist's easel for, you put your portrait in there and then you paint on there and you keep your paints in the drawer. So this is another project which I think is a lot of potential. I'm going to add on a maximum power point tracking system. So that's a kind of advanced electronic system for squeezing the most electricity out of a solar panel, because it continuously changes the input resistance to the power. And basically it gives you maximum power transfer from the solar panel. And in this case, it also uses 18650 batteries, except 3 of them in parallel. So again, I can get them off of old electronics. I don't have to buy them. They're e-waste. And I can give this sort of briefcase its own sort of backup battery that can make my laptop not only run but also charge from the backup. So that's probably what I'm going to do next, is add this power system to it. But for now, it works quite well just with charging straight off there on a sunny day. And obviously, the longer the cable you have, you can be in the shade while the solar panel is in the sun, which is pretty great. Okay, so finally, I guess the question is, can these storage capacitors address significant problems of lithium-ion battery durability? Something I call battery-induced obsolescence, where we start to hate our electronics devices because they don't work the way we are wanting them to, usually due to the battery failing. Um, and then, what about the critical minerals shortage around lithium and, all the rare earth minerals that we are using? So, just thinking about the powerful magnets and speakers, for example, all of that I'm getting back off of cars without consuming new ones. So, could we uh, could we make the consumer electronics industry shed its fast cycling practices? I'm not quite sure if we can influence them entirely with alternative open culture, but hey, the 60s had an effect on the world. So um, in that sense, I think if enough people change the way they do things, they can influence the way larger organizations behave with respect to the frameworks that they enact. And certainly frameworks like the Open Hardware Summit and so on, and the conference that Don is would like to read a little more about the historical work or some more things that I built, which I've only touched on some of the ones that would be most of interest. And then, of course, just because it's summer doesn't mean we need to concentrate solely on solar. In the wintertime, you could actually harvest energy off of waste heat. So, there are things you can do to power electronics in other alternative ways, which we might be taking advantage of. And particularly when we have ice storms like this is a picture from my street. It's important to have more self-reliance, I think, really. So thank you so much. And I guess we're at questions. I'll just stop the sharing and maybe we could stop the recording.